This video is on Unit 4, the binomial distribution example 4.7. It says a local swimming club, in a local swimming club, I guess, the mean number of people that can swim a mile is 4.5 and the variance is 3.15. So the mean is given and the variance is given, okay? And the random variable here seems to be the number of people that can swim a mile, okay? Now, the question, the first part is state and describe the random variable, which of course we don't suspect already. N is not provided, and the probability of success is not given, so we have to use N and P. And it says find the probability that at least 3 people can swim a mile. At least 3, that's from 3 onwards, so we can do a 1 minus P of less than 3. Okay, less than 3 means from 2 downwards, 2, 1, 0, I guess, and subtract from 1. So we need to find N and P using the mean and the variance. So let's see how part A and part B are answered, starting with part A first. The solution says the number of people that can swim a mile is the random variable, and it is denoted by the letter X. So anytime you see X in this example, you've got to say the number of people that can swim a mile. And the number of people that can swim a mile approximates a binomial distribution with a sample size N and a probability of success P. And it goes on to say the probability of obtaining one person that can swim a mile in every trial is a constant P. So let's move on to part B now, which is asking for the probability that at least 3 people can swim a mile. So to answer this question, we know that the mean is 4.5 and the mean is given by N times P. And the variance is equal to 3.15, which is given by NP times 1 minus P. Now, if we replace NP with 3.15, we have NP with 4.5. Okay, remember the variance is 3.15. So we have 3.15 is equal to 4.5 times 1 minus P. Okay, because NP is 4.5. It appears to be that the variance formula has the mean, as part of it. And so here we have 3.15 is equal to 4.5 times 1 minus P by virtue of substituting 4.5 in the place of NP. And we can simply divide by 4.5 on both sides, and that gives us 1 minus P. And to solve for P, now we add P, and we subtract 3.15 divided by 4.5. And this gives us P is equal to 0.3. Now with P now we can solve for N because we know 4.5 is equal to NP. So basically now N now would be 4.5 divided by 0.3. And here we have it. If we replace P with 0.3, in 4.5 is equal to NP, we have 4.5 is equal to N times 0.3, and we divide by 0.3 on both sides, we get N is equal to 15. So now we have N and P, we can find the probability of at least 3. As we said, the probability that X is more than or equal to 3, that's the symbol for at least 3. That will be 1 minus P of X less than or equal to 2. Or P of X less than 3. Less than 3 is the same as less than or equal to 2. Now, less than or equal to 2 will be from 2, 1, and 0. So we apply the formula for 2, 1, and 0. For 0, you have 0.7 raised to the 15 because n combination 0. 15 combination 0 is 1. 0.3 raised to the 0 is 1. So we are left with 0.7 raised to the 15. That's for P of X equals 0. P of X equals 1 is our 15 combination 1. 0.3 raised to the 1. 0.7 raised to the 15 minus 1, which is 14. Plus 15 combination 2. 0.3 raised to the 2. 0.7 raised to the 30. Now the plus came from the word and, because less than or equal to 2 means 0 or 1 or 2. And or in probability and in analysis is addition, and is multiplication, but the word or is addition. So you see P of x equals 0 or P of x equals 1 or P of x equals 2. That's P of x equals 0 plus P of x equals 0, 1 plus P of x equals 2. And here we have the calculations. So you add all of these and you subtract it from 1 and you get 0.8732 for the probability that the number of swimmers that can swim 1 mile is more than or equal to 3. 0.8732. And here we have both A and B, the solutions thereof in its entirety.